Hi class, how are you today? That's trigonometric. Okay, even I'll admit that one was pretty bad. Sorry. The learning target for today is to use trig ratios to find angle values of right triangles. 3. You can use trig ratios to find angle values of right triangles. 2. You can find the trig ratios of triangles, but you can't use them to get to angles. 1. You know the ratios of trig functions, so you can't put it into a triangle and find natural numbers, but you know that, say, sine is opposite over hypotenuse. We'll get into what that means in a moment. And 0. You do not know the ratios of trig functions. Let's get started. Alright, let's start off by explaining what trig ratios are. So there are 3 well-known, mostly used trig functions. There are others, but the 3 that are used the most are sine, cosine, and tangent. And each of those have ratios regarding a right triangle. So you can take the sine, cosine, or tangent of any of the acute angles in a right triangle. So in this picture here, you can take the sine of A or the sine of B, the cosine of A, the cosine of B, the tangent of A, the tangent of B. We don't do anything to C because we already know what C is. C is a 90-degree angle, and so the sine, cosine, and tangent of 90 degrees, it's never going to change. It's always going to be whatever value it is. So each of these trig functions have a different ratio regarding the angle that you choose to take the trig function of. So the sine of a function of an angle, the sine of an angle is known as the opposite side over the hypotenuse. So let's use this as an example. Say we have the sine of A, and sine is always abbreviated SIN, but it's pronounced sine. So if I want to find the sine A, that's going to be equal to the opposite side divided by the hypotenuse. Well, A is right here. The opposite side is the side that doesn't touch A. So that's this one right here, 3. So sine of A is 3 over, and then the hypotenuse, which is 5. So the sine of A is 3 over 5. Now let's look at cosine. The cosine, the ratio is adjacent over hypotenuse. So again, as an example, let's say cosine of A, and the abbreviation for cosine is COS. So the cosine of A is equal to, now the adjacent side is the leg that touches A. So you know that 3 and 4 are the legs. The one that A touches is 4. So cosine of A is 4 over, and then the hypotenuse, which once again is 5. Now for tangent. Ratio for tangent is opposite over adjacent.
And as an example, the tangent of A, abbreviated TAN, is equal to the opposite side. So from A, the opposite side is 3 over the adjacent side, 4. Now you're going to have to remember these ratios. One trick that is often used is abbreviating all of them to be written like this. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Socatella. This is used quite a bit to remember which ratio belongs where. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So sometimes you're going to get a problem that just says, find the sine of an angle. This is very difficult to do without a calculator. By very difficult, meaning, except for a small few, I can't even do these. So you're going to need a calculator. Specifically, you're going to need a calculator that can do trig functions. So if you have a calculator right now, grab out your calculator. So before you do anything, always make sure that your calculator is in degrees. What that means is calculators have different settings about how to do trig functions. And there are actually multiple ways to measure angles. As of this point, we've always done them in degrees, and we're going to keep doing them in degrees. It's in later classes that you will find out how to do them in radians. So, for now, you need your calculator in degrees. So, all calculators are very different, but usually somewhere on your screen you want to see something that looks like this, DEG, meaning degrees. If that is highlighted, then you are most likely in degrees. On the calculators in my class, the way to change this is a button that says DRG. And you keep pressing that until DEG is highlighted on your screen. If you use a graphing calculator, you would go into the mode button and switch into degrees. If you're not sure how to do that on your calculator, please let me know. So, now go into your calculator and type in sine of 32 degrees. So you press the SIN button and then press 32, and it should come up with something that looks like this, where it'll say sine parentheses, and then you put in 32, and then you want to close the parentheses. Then press enter, and it'll give you a long decimal, and unless you get directions that tell you differently, please round to 4 decimal places. So round to 4 decimal places, that would be to the nearest 10,000th. So sine of 32, that would become 0.5299, because the next digit after that is 1, which would round down. And it's no different from doing cosine or tangent. All you do is just press the cosine button or the tangent button instead of the sine button. So we're also going to have to learn how to do what's called the inverse sine. And it's written like this: sine with a -1 here. Now it looks like sine raised to the -1 power. That's actually a different thing. So whenever you see this, just take it as the inverse sine. So on your calculators, you want to press a button, on my calculators at least, and on graphing calculators, you want to press a button that says second. And then after you press that button, you press the sine button. And that should give you sine to the -1. And I'll have a parenthesis there. Then you put in the number 0.4532. Hit enter. Again, round to 4 decimal places. And that'll be 26.9492 because it was 17 and then that rounds to a 2. You'll have to know how to do this in the next example that we're going to do. Alright, so in this example, we're given a triangle ABC, and the two legs measure 2 and 5. And they want you to find A. So they want to know what is the measurement of angle A. So the way that you have to find this out is using trig. So they give you two measurements, the 2 and the 5. You have to see what side are they relative to angle A. 2 is opposite angle A. So you have an opposite. And 5 is adjacent angle A. So you also have an adjacent. Which trig function deals with opposite and adjacent? That would be tangent. So that means that the tangent of angle A is equal to opposite over adjacent, 2 over 5. So we know that the tangent of A is 2 over 5. Now what we want to know is what is angle A? So we have an equation here, and just like any equation, we have to do the opposite to both sides. So we have a tangent here. So what we have to do is do the opposite of tangent to both sides, what's known as the inverse tangent, which I just mentioned before. So A is going to equal the inverse tangent of 2 over 5. So if the tangent of A is 2 over 5, then A is equal to the inverse tangent of 2 over 5. So in your calculators, you would find out what is the inverse tangent of 2 over 5. And round to the nearest 4 decimal places. So A will be approximately equal to 21.8014. So we found what angle A is.
Now time for the sponge. For number 1, I want you to find the following of triangle ABC. So the sine of A, cosine of A, tangent of A, sine of b, cosine of b, tangent of b. 6 different values. And make sure these values are fully reduced. So they're fractions, but I want them fully reduced. And number 2, find the measure of angle E, rounded to the nearest degree. So use what I taught you to find the measure of angle E. That's it for this lesson. Once again, please make sure to take notes on the entire lesson, attempt the sponge, rank yourself, take a picture of everything, and submit it all to a backpack. And have a good night.